Hello everyone. The topic which we are going to discuss today is about the crop rice. Now let's start with introduction. Rice is the staple food for nearly half of the world population. In Asia, rice is not only the staple food but also constitutes the major economic activity and a key source of employment and income for the rural population. Southeast Asia is considered to be the center of origin of rice. Now, let's see about its geographic distribution. The leading countries producing rice are China, India, Indonesia, Japan, Brazil, Bangladesh, Vietnam, Thailand, Myanmar, and Philippines. Among the rice-growing countries, India has the largest area, followed by China and Indonesia. In respect of production, India ranks second next to China. In India, rice is grown in almost all the states. Andhra Pradesh, Bihar, Uttar Pradesh, Madhya Pradesh, and West Bengal lead in the area. West Bengal and Uttar Pradesh have the highest rice production. The average yield per hectare is highest in Punjab. Now let's discuss about the different races of rice. There are three races of rice. They are Indica, Japonica, and Javanica. Rice belongs to the genus Oryza of Poaceae family. There are altogether 24 species, of which 22 are wild and 2 species, namely Oryza sativa and Oryza glaberrima, are cultivated. Oryza sativa is grown in all rice-growing areas, but Oryza glaberrima is confined to West Africa only. Coming up next is about climatic requirements. Rice can be grown under varying conditions. They extend from 8 degree to 35 degree north latitude. They can be grown up to an elevation of 3,000 meters above mean sea level. They require hot and humid climates. The average temperature required for successful cultivation ranges from 21 degrees Celsius to 37 degrees Celsius. They can tolerate up to a maximum temperature of 40 degrees Celsius. The average annual rainfall required by rice is 150 centimeters. In areas receiving less than 100 cm annual rainfall, rice can be grown with the help of irrigation. Next, we will discuss about soil requirement. Deep fertile clay or clay loam soil rich in organic matter with high water retaining capacity are most suited for rice cultivation. Soil which can be easily puddled into mud and develop crack on drying are considered ideal for raising this crop. Rice, being semi-aquatic, grow best in submerged conditions. They can tolerate a wide range of soil pH, but they prefer acidic conditions. They grow best in the pH range of 5.5 to 6.5. Now let's see about popularly known varieties of rice. Few known varieties include IRAs, Jaya, Padma, Pankaj, Jagannath, Ratna, Gobind, Navin, Satabdi, Chyttis, Lonisri, CAUR1, CAUR2, CAUR3, and CAUR4. Next, we will see about the suitable sowing seasons. There are 3 distinct seasons for cultivation of rice in India. They can be grown as autumn or pre-kharif season crop. They are also known as aus or ahu. The sowing may be done in the month of May up to June. Harvesting may be done in the month of September and October. Next is winter season or kharif season rice, also known as aman or sali rice. Sowing may be started in the month of June and may be continued up to July, and the crop matures in the month of November and December. The next one is summer or rabi season rice. They are also known as Boro season rice, and the sowing may be done in the month of November and December, and the harvesting in the month of March and April. Next, we will see about the seed rate of rice. Seed rate varies according to the cultivation methods followed. In case of broadcasting, highest amount of seed of around 100 kg per hectare is required. In case of drilling behind the plow, 60 kg per hectare of seed is sufficient. In case of dry wet nursery, 80 kg per hectare of seed is sufficient. And in case of wet bed nursery, 40 kg per hectare of seed is required. And in case of depot method, 20 to 25 kg per hectare of seed is required. And in case of SRI, 6 to 8 kg per hectare is sufficient. Now let's see how seed treatment can be done. Seeds should be dipped in a sufficient amount of water, and only those seeds which are settled at the bottom are to be collected, discarding the floating seeds. Seed treatment with carbendazim solution at the rate of 2 gram per liter of water for 1 kg of seed prove effective against fungal diseases. After taking out the treated seeds from the solution, it is covered with moist gunny bags and allowed to sprout by sprinkling water frequently on the gunny bags. Now let's see about the different methods of cultivation of rice. Rice can be grown with the following methods. The first one is dry or semi-dry offland cultivation. This may be done either by broadcasting the seeds or by sowing the seeds behind the plow or drilling. The another one is wetland or lowland cultivation. This may be achieved either by transplanting in puddled field or by broadcasting the sprouted seed in puddled field. Next, we will see about dry or semi-dry offland cultivation. The first one is broadcasting the seeds. This method is practiced in those areas which are comparatively dry and less fertile and do not have much labor to work in the field. The seeds are broadcasted immediately after the onset of the monsoon showers. The second one is sowing the seeds behind the plow or drilling. Seeds should be drilled using seed drill, or it may be sown behind the plow in rows after applying fertilizers. Next, we will discuss about wet or lowland cultivation of rice. First, we will discuss about transplanting in puddle fields. For transplanting, first we need to raise nursery Now we will see how wet nursery bed is to be raised. Land is plowed thoroughly, puddled with around 3 to 5 cm of standing water to obtain a soft seed bed. A raised seed bed of 5 cm high, 1 meter wide, and of convenient length with channel of 30 cm wide all around the seed bed is to be prepared. Area required is around 1/10 of the main field. The sprouted seeds are then broadcasted uniformly. The bed should be kept saturated with water after 18 to 24 hours of sowing up to 5 days, and then gradually increase the water level up to 5 cm depending on the height of the seedlings. Farmyard manure at the rate of 2 kg per meter square nursery bed area should be applied before seed bed preparation. In less fertile soil, basal application of 0.05 kg DAP per meter square nursery bed prove beneficial. Now we will see about dry nursery beds. The nursery site should be free from seeds. This method is almost same with wet nursery, except that in this case the nursery is raised in unpuddled dry soil. Next we will see how depot nursery can be raised. Depot nurseries are generally prepared in flat firm surface. Area required is around 1% of the main field. The seed bed area should be covered with banana leaves or plastic sheets. Cemented floor may also be used as base. Seed bed size of around 1 meter wide and 10 to 20 meter long is marked out with bamboo splits or banana seeds, and then cover the seed bed with a mixture of 8 buckets of soil plus 2 buckets of compost plus 1 bucket of rice hull in each square meter. Sprouted seeds are then broadcasted uniformly on the seed beds. Seed beds should be sprinkled with water 3 to 4 times a day, and thereafter 1 to 2 cm of water is to be maintained till the seedlings are ready for transplanting. Now let's discuss about land preparation for main field. Land should be plowed 20 to 25 cm deep by using moldboard plow. An earthen bun of about 30 cm high should be prepared around the field. This should be kept flooded and allow water to soak in for about 1 fortnight. Puddle the field 2 to 3 times by running puddler in standing water. Now let's see about the optimum age of seedlings. During Kharif seasons, 21 to 25 days after sowing. During Rabi season, 30 to 35 days after sowing. And in case of SRI, 10 to 12 days after sowing. And in case of depot method, 11 to 14 days after sowing, and in dry areas 30 to 35 days after sowing. Next, we will discuss about transplanting. As far as possible, delayed transplanting should be avoided because it leads to poor tillering, early flowering of the main tillers, which results in the reduction of yield. Transplant 2 to 3 seedlings under normal conditions, and if transplanting is delayed, number of seedlings may be increased. Shallot planting ensures quick establishment and more tillers. Next, we will see about how much spacing needs to be maintained in case of rice. For high-yielding variety, 20 cm by 10 cm or 20 cm by 15 cm, or it may be 15 cm by 10 cm. In case of hybrid rice, 20 cm by 20 cm is optimum. And in case of SRI method, 25 cm by 25 cm, or it may be 30 cm by 30 cm also. Now we will see about broadcasting sprouted seed in puddle field. This method is adopted in areas where there is shortage of labor. In this method, field preparation and puddling is to be done in the same manner as in case of lowland transplanted rice. The required amount of seeds are pre-germinated by soaking in water overnight and then broadcasted uniformly. Next, we will discuss about manures and fertilizer application. 10 to 15 tons of farmyard manure should be applied few days ahead of sowing. Application of fertilizer should be done as per the soil test value. However, general recommendation as given below may be done. Next, we will see about fertilizer dose in terms of NPK ratio. In case of rain-fed upland, 40-20-20 kg per hectare, and in case of lowland kharif irrigated rice, 60-30-30 kg per hectare should be applied. And for rabi season rice, 80-40-40 kg per hectare should be applied. And for hybrid rice, 100-60-60 kg per hectare is sufficient. And in case of aromatic rice, 60-30-30 kg per hectare is sufficient. Coming up next is about the scheduling of fertilizer. Nitrogen should be applied in 3 equal split doses. 1/3 nitrogen as the basal dose, another 1/3 of nitrogen at early tillering stage, and the rest during panicle initiation stage. Before top dressing with nitrogen fertilizer, water should be drained out and water is allowed to let in 24 hours later. For late planted conditions, nitrogen may be applied in 2 split doses, 65% as basal and another 35% at panicle initiation. Phosphorus and potash fertilizer should be applied as basal dose depending on the soil test values. In light soils, potassium may be applied in 2 splits, that is, as basal and another at panicle initiation stage. Use of azolla can provide 20 to 25 kg nitrogen per hectare. Another method of scheduling fertilizer is based on the reading of leaf color chart. LCC, that is leaf color chart, is used to determine the nitrogen needs of rice crop. It has 4 green strips with color ranging from yellow-green to dark green. It determines the greenness of the rice leaf, which indicates its nitrogen content. Steps of using leaf color charts. After 15 to 20 days of transplanting, color of some healthy leaves from the representative area is matched with the leaf color chart by putting the leaf on the strip of leaf color chart. If the observed value falls below 4, then apply 55 to 60 kg urea per hectare, and if the value falls below 3, then apply 45 to 50 kg of urea per hectare. Same procedure may be repeated at an interval of 8 to 10 days till flowering stage. While taking the reading with leaf color chart, due care should be taken not to let direct sunlight fall on the leaves as well as the leaf color chart. Reading should be taken during morning hours. Next, we will discuss about water management. Water management should be done as given below. Maintain water to an extent of 2.5 cm height in the field during first 10 days of transplanting, and afterward increase the height up to 5 cm whenever required. Irrigate the field 2 to 3 days after complete infiltration of the stagnant water and maintain the water level to an extent of 5 cm from panicle initiation stage to panicle emergence stage. Drain the field 1 week ahead of harvesting. Critical stages of irrigation are: first is tillering, next panicle initiation stage, third one is budding, and the fourth one is heading or panicle emergence, and the last one is flowering. Now we will discuss about weed management. The most effective way of controlling weed is integration of chemicals along with 1 to 2 hand weeding after 30 to 35 days after transplanting and at 60 to 65 days after transplanting. Few commonly used herbicides are listed below. Butachlor at the rate of 1 to 1.5 kg per hectare, Anilophos at the rate of 0.4 to 0.6 kg per hectare, Pretilachlor at the rate of 0.6 to 0.8 kg per hectare are some of the widely used pre-emergence herbicides. These are generally applied 4 to 7 days after transplanting. Post-emergence application can control weeds effectively when applied at 20 days after transplanting. Propanil at the rate of 2 kg per hectare can be used in such case. Next, we will discuss about major insect pests. Rice crop may be attacked by stem borer, gold mitts, green leaf hopper, leaf folder, rice hispa, Gandhi bug, etc. And next we will see about major diseases of rice. They may be attacked by leaf blast, whose causal organism is Pyricularia or rhizae. Next is seed blight, whose causal organism is Rhizoctonia solani. And the next is brown spot, and causal organism is Helminthosporium or rhizae. The next one is false moth, and whose causal organism is Ustilago species. And another one is seed rot, whose causal organism is Serocladium or rhizae. And the next one is stem rot, and the causal organism is Sclerosium or rhizae. Now we will see about how harvesting can be done. The right stage for harvesting is when panicle turns into golden yellow and the grain contains about 20% moisture. In terms of number of days to mature, rice crop usually mature within and around the period of 120 days. Harvesting can be done manually by using serrated sickle and also mechanically by using combine harvester. The plants should be cut and left in the field for a few days to dry. Later on, they should be collected in bundles and then stacked for threshing. Next is about threshing. Trampling by bullocks or lifting the bundle and hitting them on the raised wooden platform or any other hard surface is the most common method of threshing. Pedal thresher or power-driven machinery are also in use. The threshed grains should be winnowed properly. Next is about storage. For safe storage, the grains should be dry in the sun for about 1 week. The safe limit for proper storage is about 12% moisture content. This much is about the conventional or traditional methods of rice cultivation. Now we will discuss about few resource-conserving rice technology in rice cultivation. First, we will discuss about system of rice intensification. The system of rice intensification is the new and promising resource-saving method of growing rice under irrigated or rain-fed conditions. Studies in numbers of countries have shown a significant increase in rice yield with substantial savings of seeds 80 to 90%, water 25 to 50%, and cost 10 to 20% compared to conventional methods. SRI is not a technology but a set of simple ideas and principles that help to produce more productive and robust tillers. SRI is based on the following principles. First, young seedlings between 8 to 12 days old, that is at 2 to 3 leaf stage, are transplanted to preserve the potential for tillering and rooting ability. Second one is careful planting of single seedlings rather than in clumps that are often planted in the soil. Third one is wider spacing at 25 cm by 25 cm in square planting rather than in rows. Fourth one is use of cono weeder to aerate the soil as well as for controlling weeds. Fifth one is alternate wetting and dry method rather than continuous flooding. And the last one is use of organic manure. Next resource conserving technologies I would like to mention is about aerobic rice. It is a new concept of growing rice using less water in non-puddled aerobic soil using supplementary irrigation just like upland crops. Aerobic rice cultivation is done in well-drained, non-puddled and non-saturated soil without ponded water. Various research studies have shown profitable results when rice was grown under dryland conditions using sprinkler or flushing irrigation rather than flooding, indicating that rice do not necessarily require flooded conditions for high yields. However, new aerobic rice varieties and special design management strategies are needed for these systems to be successful. Now, coming to conclusion, rice cultivation is not an easy task and requires a great deal of patience. In addition to this, there are different methods of cultivation of rice. In our country, rice is mainly grown by transplanting methods in puddle field, which require huge amount of water, manpower, and energy. On the other hand, direct seeded rice, which require less water and manpower, is unable to compete with the transplanted rice in respect of yield. Few other cultivation techniques which can eliminate the above-mentioned crises includes SRI, and aerobic rice. Thorough understanding of the different cultivation techniques is very important in order to find out the suitable cultivation methods that are resource conserving and profitable for farmers, consumers, as well as the environment. Thank you.